Welcome to Study Loop.
In this problem, we're told that the rate of change of the atmospheric pressure with respect to altitude, which we would describe as dP/dH, is proportional to P. And is proportional to P means it equals some constant K times P. And whenever we have a relationship like this, what we've seen in this lesson is that it translates to the exponential growth and decay equation, which would be P equals P naught times e to the k times h. So we can use this equation to solve the problem in addition to the initial conditions that were given. We're told that at a height of 0, the pressure is 101.3 kilopascals, and we're told that at a height of 1,000 meters, the pressure is 87.14 kilopascals. So let's use that information and find the value of K. All right, so we're going to substitute 87.14 in for the final pressure and 101.3 in for the initial pressure. And we'll substitute 1,000 in for the height, and we'll solve this for K. So we'll divide both sides by 101.3, and as a fraction, that ratio is going to simplify to be 4,357 over 5,065. So that equals e to the 1,000k. Then we take the natural log of both sides. And then we divide both sides by 1,000, and we'll have the value of K. All right. Now this is not a very user-friendly number. It's around negative 1.5 times 10 to the negative fourth. So what I decided to do is store this in my calculator so that I don't lose any accuracy when I go to use it again. All right, so now we want to use that value in our model, and our model is P equals 101.3, the initial pressure at 0 degrees of altitude, times e to the k. I'm just going to call it k for now. We know the number, but I don't want to write that number every time. So k times h. So let's use that model to do parts A and B. So for part A, we're finding the pressure at an altitude of 3,000 meters. So we substitute 3,000 in for h. We're going to use the k value that was stored. Put that in the calculator, and we get approximately 64.48 kilopascals. Now, the book answer is very close. They have 64.59. Could be that a rounded value was used to get the book answer rather than the exact value that I used. So I suspect that mine might be slightly more accurate because I didn't round anything. Now we're going to go on to part B, and we're doing the same thing, but we're finding the altitude. We're finding the pressure at an altitude of 6,187 meters. And that would be the top of Mount McKinley. So we substitute 6,187 in for the height. Use your stored value of K. Put that in the calculator, and we get approximately 39.91 kilopascals of pressure. And the book has 40.05. Again, probably just a rounding thing.